Hello everyone, welcome to this webinar on the contextual digital twin, which was originally delivered at the 2019 Royal Institute of Naval Architects ICAS conference in September. And what we're doing is we're just presenting this as a webinar to make it available to a wider audience. Because our aim at Vertalis has always been to assist engineering organizations in delivering in the most efficient manner possible. And we do this by facilitating collaborative working and for engineers to make decisions at the earliest possible stages in a product's life cycle so that they can have the biggest impact in terms of reducing risk, cost, and time to market. And this mission remains unaltered and equally relevant, but the digital transformation that is sweeping industry means that we ourselves need to take stock of how we can continue to deliver against that background. Now, the focus of this webinar is going to be to communicate some of our findings in this regard and to illustrate the importance for every organization to similarly take stock of their relationship with existing and emerging technologies and tools. And specifically, we're going to define some of the basic concepts. We're going to cover the digital twin and make the case that the digital twin is not an end in and of itself, by which I mean that the benefits from it do not flow to an organization simply by virtue of having such a twin. However, there is great potential for the organization that thinks carefully about the entire product lifecycle and considers the technological frame through which it regards the digital twin. And this includes taking into account not just the way in which the business operates now, but also what it may have to look like to remain competitive and what other business models are potentially open to it when the broader commercial and technological environment is considered. And finally, I'll go on to talk about some of the key components of a contextual digital twin and how it can be consumed, which is really the vision that Vertalis have in this area. But given that the thrust of this discussion is about context and cognitive frames, it's only fair I give you some insight into what defines ours as an organization. So Vertalis is a UK-based business in Manchester, which is specialized in delivering connective immersive visualization systems and software to engineering organizations for over 30 years. We have customers covering industries from geoscience through to aerospace and of course shipbuilding. And you can see some of the logos of those organizations on the right here. And our customers already use us across a range of applications from feasibility studies, design reviews and factory layouts, through to procedural and scenario training and bid support. We can run our software, GeoVisionary and Visionary Render, on a range of hardware devices from head-mounted displays, custom-built caves and other custom setups, through to handheld devices and laptop PCs. And our systems group has decades of experience in designing and installing bespoke virtual reality facilities to suit individual requirements. My role in the organization is the product manager for the Visionary Render and GeoVisionary product lines. Okay, so introducing technology frames. So this is the idea that the way a technology is picked up and used is not simply an artifact of its design and manufacture. And it's an idea that came out of a school of thought called the social construction of technology, to which I'm not going to pretend to do any justice today. But really what we're saying is technology is not deterministic. And it's really about how we look at it that influences its usage. And as evidence of just how important a factor that is, I would look no further than the fact that just about every organization of any scale has some form of marketing department, because every organization recognizes this as being a truism. They need to instruct and coach and nurture the market. And to illustrate that concept, we're going to look back in time a bit to the 19th century and consider the penny farthing. So our perception of the penny farthing is probably of a faintly ridiculous transportation tool that only existed for as long as no sensible alternative existed. But in fact, the penny farthing was enthusiastically adopted by a particular group of people, generally younger athletic men, who welcomed it as a tool to help them show off both their ability to negotiate something which was quite frankly dangerous and extreme, but also their athletic prowess, and racing was a popular activity on them. Now, to these people, the advent of pneumatic tires and mechanical gears and chain linkages, which allowed the size of the front wheel to shrink and make it less likely that they would be seriously injured in a crash, wasn't of particular value to them. All those factors were simply aspects that made this a more desirable tool. The more extreme, the better in some regard. And the adoption of the ordinary bicycle, as we see it here, wasn't something that was taken up wholesale upon its entry to the market. For the users of the penny farthing, they really did welcome the advantages they perceived it offered them and stuck with it. And when we think back to digitization, the message is this: the full value of the digital twin isn't waiting for the next technological innovation. What it does require us to do is to really think about how we consider it as an artifact. And we need to do this across the entire value chain and for the context of the business we work in and the environment it itself competes in. Moving on to the digital twin itself, as a concept, it's a powerful one, which is precisely why we hear so much about it these days. And a complete digital twin, one that truly captures all the data associated with the design or of an as-built asset, theoretically opens up the possibility of a range of extremely valuable activities to be undertaken sooner in the process, throughout the life cycle of the asset itself, as well as facilitating new types of analysis through the use of artificial intelligence and feedback from the connected in-service fleet. But practically speaking, there can be many barriers to realizing the full value of the digital twin in practice. And this webinar will look at how some of the more fundamental ones around accessibility may be overcome. And as a final note on the digital twin, it's worth saying that while definitions and approaches are still settling down, there appears to be little doubt that the value of it is broadly recognized, and increased adoption appears to be the universal prediction, even if there's some uncertainty and variability in the absolute value of this market in a few years' time. Nevertheless, its impact across the value chain is patchy and generally concentrated upstream. And in some sense, it's an emerging technology, so that's not necessarily surprising. Nevertheless, this may not be a sustainable position, particularly when the impact of wider industrial trends and technological advancements like the industrial Internet of Things and connectivity are considered. And to explore that idea a little further, I'll make reference to a related concept, the product lifecycle management system. And in this study that we see in the table on the left from a 2012 report by the Aberdeen Group, it's indicated that the consensus is that a PLM, product lifecycle management solution, is about managing data and processes in developing new products, and comparatively little emphasis is placed on downstream phases, which isn't an approach that lends itself to the ecosystem economy, where relationships between suppliers, integrators, original equipment manufacturers or OEMs, and end users may be redefined from the traditional transactional model. And just to explore that topic a little further, Aerospace was probably the first of the industries to go down the route of an ecosystem economy. And this was driven largely by the cost and complexity of the aircraft and the systems involved. And one of the most striking changes was the move to what's termed power by the hour by gas turbine suppliers, in which the airlines lease their power plants in terms of their usage rather than buy them outright or even lease them on a calendar contract basis. But similar business models are even being used for supplies of systems like galleys, the onboard kitchens, whereby performance guarantees are expected and penalties incurred if they're not fulfilled during the in-service life of the aircraft. So it's a move from a supplier and OEM type model to one where risk is shared between everyone involved in that project throughout the lifetime of the project. And another example, perhaps particularly striking as the motivation, is an expectation that the traditional business model on which they operate will significantly change in the short to medium term, is in the automotive industry. When we're seeing there that even the giants like BMW and Daimler are having to pivot and react to advancements in technology such as connectivity and automation, which has facilitated the entry of a number of new competitors, both large and small, so like Google, Uber, and quite a number of startups in Asia and America. And in order to react to this, Daimler and BMW are partnering, and they're setting up joint ventures in order to allow them to become mobility solution providers rather than manufacturers of cars. And they're not alone in this. Ford themselves, the Ford Group, have started to define themselves as a mobility solutions provider. And JLR, I've heard at conferences talk about the fact that they won't hit their targets and their business plans by being car manufacturers alone. They're all having to react to this. So while this change might not be as marked or as rapid in other industries, it does seem inevitable that most will undergo some degree of change in the next few years in response to either emerging technologies or social trends, or, as we're going to suggest here, both. Okay, so the final term to cover in this before we move on to really the meat of it is the concept of the product lifecycle. And it's a much more widely understood phrase and typically varies little from definition to definition or industry to industry. And it just so happens that the example I've selected here happens to come from the shipbuilding industry. But the fundamentals are relatively familiar to most. Nevertheless, there is a risk that our traditional definitions don't capture the complete cycle, or those people who are important stakeholders at various stages within it, which goes back to the earlier point that in discussing the digital twin, we front load the emphasis to those at the design and production phases. And the idea of managing requirements is perhaps more familiar to the software industry, but as the pace of development increases and the idea of making changes and having changes happen in service and software updates over the air, however it may be done, and it does seem like it's a consideration that needs to be considered more explicitly. And then around all this is the sales and marketing departments, not traditionally perhaps regarded as being part of the product life cycle, but we've already discussed how important marketing is to the adoption, usage, and requirements definition of a product or asset. And so it doesn't seem unreasonable that this is in place. But sales, particularly for assets like aircraft or ships or complex plants, where the commitment needs to be made by a customer early, many years perhaps before the system itself is in service, the sales team really do need access to some of the material contained within the development process from an early stage. And then beyond the organization itself, there are any number of classification authorities, emergency services, insurers, etc., who could benefit from having access to some subset of the information contained therein. And the emphasis really is on that phrase subset. And there's no suggestion that everything should be available to everyone as a matter of course. Not only would that be undesirable, it would probably be counterproductive, as we're going to go on to see. But if it is the case that our emphasis is currently skewed towards the design and production phase, what are the implications? Well, it really goes back to that table from the Aberdeen group. The risk is that a digital twin becomes a repository for design and build data. And it's possible that that same group who put that info in the first place may come back to it to use it as a reference point for future refit or decommission, perhaps as a data point for the generation of the next iteration of that product. And it may even become a holding point from data gathered in service. But the risk, of course, is that we continue to only serve a small number of the total potential stakeholders who could benefit from this input. Conversely, the true potential of the digital twin is both much broader than that, and it offers the potential for new possibilities in terms of business models or design processes, or just the way that we service or look after that asset throughout its lifetime. And ultimately, it can deliver great value across the whole life cycle and do that for consumers and stakeholders traditionally excluded from it. But as mentioned, there are many barriers to be overcome for this to be fully realized, and focusing here only on those at the consumer side, the consumer as in those who might wish to access it, no matter what organization or department they're part of. We can break it down into four broad categories. Starting at the bottom left, we can see that the most fundamental barrier is that the system itself is restricted. They can't even get access to the system that hosts the data. And moving over to the right, it could be that having gained access to the system, the user is then prevented from making any progress because they don't have the necessary license to access the data contained within that digital twin. And then, having got access to the required software, it could be that they're faced with something they don't feel comfortable in using. They're not trained on the tool, or if they have been trained, it was sufficiently far in the past that they're not comfortable in picking it up and using it confidently to get the information they need. And then finally, even if all that has been overcome, let's think again about the context of the user. They're probably thinking in terms of their use case, their department, the data they understand. All that could be hidden amongst a sea of other information which is useful to any number of other people, but simply acts as noise to them. So in both those last cases, where we're talking about data hidden amongst the noise, or a lack of training, we're talking about a situation where that potential consumer is likely just to revert to the previous means of getting that data, whatever that may be, probably emailing someone, relying on someone else to do it for them. And that is obviously less than desirable. It's not particularly efficient. So this is why Vertalis are suggesting we need a contextual digital twin, one that serves up what is needed on demand in a secure and accessible fashion. And we've defined here 5 core aspects of this contextual digital twin. It needs to be routinely available. It needs to genuinely touch each stage of the product lifecycle. It needs to be secure. So what is shared and with whom is controlled both in binary terms, available or not, and temporally, so that uncontrolled instances don't exist outside of the control of the central data source beyond a time period for which it's appropriate to do so. It needs to be hardware agnostic, and more than that, actually, it needs to be hardware optimized. So no matter how your consumer is choosing to access the digital twin, the presentation should be appropriate and useful. And it needs to be context sensitive. So now we're back to thinking about the frame of reference for that consumer. Are they interested in data to do with maintenance, with stress levels, with classification? Whatever it is, it needs to be served up in a way that they expect it to be presented. What is it they wish to achieve with it? So making it easy to process that data to whatever end they want it for. And it needs to be, of course, intuitive. And the system needs to be performant, particularly again when we're thinking about large and complex systems. A blocker to making any progress with this could be that yes, you can call it up. Yes, it's intuitive, but you've got time to go away and make 3 cups of tea, or you could be waiting hours for the information to be served up. The system needs to be performant so that when you want it, the information is there. In all cases, we want to make sure that the end user isn't feeling obliged to revert back to their previous method of accessing the data, or if they were previously excluded from this system altogether, to simply not asking the question in the first place. And the endpoint of such a system, we maintain, needs to be a visualization tool that can immediately place the user in the context of the issue at hand, be that a maintenance question, project proposal, training scenario, or design review. And that's why we advocate this notion of connected immersive visualization. And that's not just simply another way of reviewing 3D CAD. We're talking about linking in with organizational and project data in order that we facilitate that clear decision making I mentioned at the start of this presentation. And ultimately, it allows functional specialists to communicate clearly to those in other departments, which in turn means that the project issues, requirements, and status can be readily understood and managed. And this is exactly how we see our users benefiting from these visualizations right now. It really is about cutting through protracted discussions or confusion, placing different stakeholders in an immersive scene, and the context and the issue almost immediately jumping out and becoming clear. And while this is the front end of a contextual digital twin, and it's what we've been doing at Vitalis for some time, in order to hit all of the points noted as being essential components of a contextual digital twin, we need to also consider how this endpoint will be served. And this is essentially the vision. So to recap, we say that this contextual digital twin needs to be routinely available, secure, hardware agnostic, context sensitive, and performant. And the starting point for such a system needs to be a shared backend service, which administers access, hosts data, and applies rules and templates to that data in order to generate the scenes. So more than likely, and again, depending on the organization, it's going to be some type of cloud-hosted backend service. And in this high-level architecture at the bottom, we can see that we're bringing in data from any and all of the required data sources. So it's not just CAD, it could be the SAP system, PLM, MES, CAD, and it's brought into the visualization database via, if required, integration and translation. And also within this backend system are the templates which will be applied to this data, and in so doing creates the visualizations themselves, which will be picked up by the end user. And these templates would be aligned to the roles or tasks that the end users wish to do, such that the comprised visualizations, those scenes that are going to be reviewed, presented, comprise only that data that's required for them to do their tasks. So the scenes themselves, so far we've been talking about something that exists on a centrally managed and hosted system. But when we come to the consumers, what we're talking about is a system where they would spin up on demand their presentation via a web viewer on their local client device. And that could be embedded in whatever corporate template is required. And as mentioned, it would be optimized for whatever tool is ultimately being used by the consumer. If that's some kind of HMD, as we see on the right, for maintenance, or a cave or other projection type for the design review on the left, that would be accounted for. And importantly, upon completion of the work, those visualizations on the endpoints would be closed down, and no data would be left outside of the control of the central system. So this is about ensuring that the organization retains control of the project data. It doesn't exist out in the wild. And that's a safety factor for the consumers as well. In this fashion, they can always make sure that they're picking up the latest iteration of whatever data they need to access to do their roles. Okay, so to wrap up then, we've seen how the use of technology is something that's defined by the context of the organization and the environment in which it operates. And furthermore, this is a technological frame that's currently shifting in a quite dramatic fashion due to a shift towards what we call the ecosystem economy, in which relationships between suppliers and consumers are being redefined. Now, managing all the stakeholders in such an environment requires a means of sharing relevant and up-to-date project information. The digital twin has been conceived as a means of doing this, yet there is a risk that the digital twin remains largely a tool focused on the design and engineering domains. And while important, limiting the role to these, or the technology to these functions, inhibits organizations from getting the most value from their digital assets. And to truly reach across the value chain, the digital twin needs to be freed from the constraints currently placed around it, which is something connected immersive visualization can facilitate by securely presenting clear and relevant data to any stakeholder who requires it at whatever point that may be. So thank you for your time today. Thanks for joining us on this webinar. If you do have any questions, please feel free to get in contact on info@vertalis.com. And I very much hope we hear from you soon, and you can join future webinars that we'll be putting out. Thank you.